Welcome back. We're going to continue with another homework exercise in Python. Just come to the Programming for Engineers, and this is under the assignments. Okay, so if you go to APMonitor.com/CHE263, and then on the right here you'll select homework, and then scroll down. We're working right now on assignment number 13. There's the PDF, or you can also get from the files right there, you can get all of these IPython notebook files and others that we're working with right now. So go ahead and download those and extract them. Here they are extracted. We're going to be working with the YAML file, the thermo data YAML file. If you just open that, okay, so edit with a notepad or something like that. It just has for different species like hydrogen, elemental oxygen. There's oxygen right there. So a lot of different species. It has these heat capacity coefficients, so a lot of data here. We just want to be able to load these in and work with them. So we have a problem here where we're going to, let me just come over to the IPython notebook. So just open up homework 13.IPython notebook, and we're going to be starting on problem 2. Okay, the former video showed the solution to problem 1. So we want to write a class for computing thermodynamic properties in the cell below, and we'll call the class thermo. And we'll include this initialization statement, and what that will do is just initialize when we instantiate, when we make a new instance of that class. It's going to identify which species we're going to be working with. Okay, so and then we'll write, and so just some more instructions here. There's some units things. There's also this import YAML that'll load in some of these A low and A high values. I'll show you how to do that. But the important thing is that A low is for 300 to 1,000 Kelvin, and A high is for 1,000 to 3,000 Kelvin. Okay, so we're going to import those, and based on the temperature, we'll use one set of coefficients or another. Okay, and so we're going to write this thermal class and also the new get CP. CP is for heat capacity, and we'll compute that in joules per kilomole Kelvin, and then they should take temperatures in Kelvin as an argument and then produce the heat capacity of whatever gas I had there. Okay, and then we want to make sure we use the right set of coefficients for the right temperature range, and there is my heat capacity equation right there. Okay, so let me go ahead and just insert a cell below here. This is the one that we're going to be working with, and we'll just create a new class called thermo. Okay, and within that class we can have variables or functions. We're just going to define a new initialization function here, and the first thing you always have to do is self. Okay, so you need to know which instance of the thermal function we're going to be calling, and then we're going to have an optional one as well. In this case, you can have as many of these input arguments as you want. We're going to have species. Okay, so when we instantiate it, we got to tell it what species we want. Okay, so I'm just going to import the YAML file, or the YAML package, so just like it's shown right up here. I'm just going to copy that down here, and I'll do with open, and then we'll do thermo data.yaml. Okay, so YAML file as Y file. Okay, so we'll import that and then open it, and then Y file is going to equal YAML dot load and Y file. Okay, so now it's loaded in Y file, and then we can start accessing some of this data. So the first thing I want to do is just define a new self.a_low. Okay, and that's going to be for just that instance that we're going to define. We're going to have a new A_low vector, and so that's going to be Y file, and I'll get it for whatever species I indicated. Okay, this is the input argument right here for the species, and then the next dimension is going to be a low. Okay, so it's going to go to the YAML file, and for that particular species, and then get the A low vector for that. I'm just going to copy this and then put it on the line below it as well. Okay, and copy that and do A high as well. Okay, so get A low and A high, those are just a bunch of coefficients. And then let me also define this universal gas constant. Okay, and so that's going to be RG 8314.46, and that will be in joules per kilomole Kelvin. Okay, so there is our initialization, and then we want to find one new function as well, which is get CP, get the heat capacity. And again, I have got to start it with self. That's the which instance I'm going to be calling, and then the temperature there, and that's going to be in Kelvin. Okay, so I need to select which values to use based on temperature. Okay, so based on temperature, select which values. If the temperature is less than 1,000, then I'm going to say that A is going to be self.A low. Okay, else if I'm going to use the high values instead. Okay, A high. So why do I have to use the self values here? So when it calls it, it knows which instance. Okay, so I can create multiple instances of this. Maybe one is hydrogen, another one's methane, but I've got to know which one I'm going to be using, because when I initialize this, I had the species is important, and it's going to grab the A low and A high values for that particular species. So this is just a generic function, but I want to be able to identify which I've stored it as self.A low or A high, and then I want to compute. Let me go ahead and define RG separately. I'll just use self.RG, so just create a local temporary variable there, and then I'll compute heat capacity. Okay, according to this equation that you see right above it. Okay, right up there. Okay, so we have CP is equal to RG times, and then I've just got A0 plus A1, and then times T. Okay, I'm just going to be typing this in times T squared plus A3 times T to the third. Okay, I'm almost done here. A4 times T to the fourth. Okay, so I'm all done with that correlation. I've used the appropriate A values based on if it's in the high or low temperature range. And then the final thing that I want to do with this function is go ahead and return the value of CP. So if I run that, and I don't have any errors, I haven't called it yet. But now let's go ahead and go on to part C. So we want to instantiate the class for species CH4, and we'll call this object TCH4, and so we'll do basically just start it with let's see, TCH4 is going to be equal to thermo. That was our class name, and we'll create a new instance of it with the species name CH4. Okay, so when we run this, it's going to spit out. Okay, so I'm going to let me insert a cell below. Okay, so now if I do TCH4.RG, okay, it gives me that value. If I do a low, it's going to give me those values that it loaded in. Let's just go back to our YAML file. Okay, so I just want to look at our YAML file that we had here. Let's just look at the CH4 values, just make sure they're loading in correctly. Okay, so I'm getting closer. There's CH4, and there are my values right there. Okay, so the last value for A high was about 18.4. Okay, so let's just go ahead and check that to make sure that these were loaded in correctly. Okay, so I'm going to do A high. Okay, so there's the 18.4 down here as the last line in this. Okay, so these were loaded in correctly. We can start using them. If I want to compute, get CP, and I want to calculate this at 300 Kelvin. Okay, there's my heat capacity at 300 Kelvin. Okay, so what it did is it called this get CP. I only have one argument that's implied, that you have self. That's the instance of this, which is the CH4 thermo properties that I loaded in here in the init. But I have just the temperature input, and then it returns the heat capacity. Okay, so now what I want to do is, now that I've loaded this and I've gotten a heat capacity, I've verified that it works, I want to create a plot for CP versus temperature. So we'll let the temperature range from 300 to 3000 Kelvin, and then we'll use at least 100 points. So to do that, I'm going to just go ahead and import NumPy as NP, and then I'll create some arrays just to be able to store the 100 values that I'm going to create. The temperature that I'll have, I'll just say that's NumPy linspace. I'll go from 300 to 3000, and let's go ahead and just do 200 points. We'll do a little bit of overachieving here. Heat capacity, we'll just create an empty array, and we'll just do that as same length as T, okay, because we want a CP for every T value. So the length of T, and then, so if I just print that out, length of T, okay, and then run it, I can see that the length is 200. Okay, and then it just created an empty array. If I just print CP right here, it's going to show me, it's just a random numbers. Okay, it looks like it just grabbed what the temperature was, but if I run it again, I might get different values. Okay, and then run it again. So it doesn't initialize that memory, it just takes whatever's there. If you're bothered by that, then you can always do zeros instead, and then it'll be zeros, or you can have ones and initialize it to something that you want it to initialize it to. Okay, so I'm going to go ahead and comment that out so I don't have that these two printing out. Oh, I don't need to comment that one out. I'll just comment that and this one. Okay, so all right, now we want to loop through and be able to calculate the different CPs at the different temperatures. So I'm going to create a new loop. I'll just create a new variable IT in range, and then I'll do length T. Okay, so it's going to go from 0 to 200, or actually to 199. There'll be 200 different loops through this. Okay, and then I'll do CPIT. Okay, so that's going to be our index for the temperature. It's going to start with 0 and then go on up, and then we'll just do T CH4 and then get CP, and then I've got to put in my temperature now that's indexed by the IT value. Okay, so I've got that, and then I ran it, and then let's go ahead and just create a new plot now. Okay, so what we need to do the plotting, in IPython, you've got to do matplotlib inline. Okay, so that's the very first step, so you can have it show up in line here in the IPython notebook, and then we'll import matplotlib.pyplot. This is pretty standard stuff. We'll just import it as PLT, and then we'll do PLT.plot, and we'll do temperature versus CP. I'll just do a red line there, and then let's get some X labels, and okay, and that's going to be our temperature in Kelvin, and then let's do a Y label as well, and the Y label is going to be the heat capacity, and that's going to be joules per kilomole Kelvin. Okay, and then let's give it a title as well. Okay, so that is going to be heat capacity. Okay, so there we've got it. So when we run it, now we will get a plot of heat capacity versus temperature. Okay, so now let me just show you, I know this isn't part of the assignment, but let me just show you how easy it is to create another one Let's do O2 now instead. Thermo O2. Okay, so there's another species, and you know what? I probably need to, let me create these up here. It was just out of order because I had run it before, but if you run it new again, if you try to use TCH4 before you've defined it, then there can be some problems. Okay, so I'm going to put that before I start using it, this get CP right here. But let me create another, I'll just do CP1, and then I'll have a CP2 as well. And those will just be blank arrays, and then the CP1 will be the CH4, and then CP2 will be the TO2. Okay, so I've got 2 now, and then I'll just change this CP1, have that be the red line, and then CP2, I'll have that be a blue a dashed line. Okay, and then okay, and I probably want a legend on here as well, so I can tell which one is which, and I'll have that be CH4, and then okay, and then O2. Okay, so there I've got a legend on my plot. So let's go ahead and run this now. Go and run this one, and then this one, and so there I've got the O2 heat capacity versus the CH4 heat capacity on one plot. And you could add other species as well. So this is an example of how to create a new class. So we created a new thermal class. We initialized it by calling which species we wanted, and then it basically just used this YAML file to to organize the data, to give us the A low and A high, and then also the based on the temperature range, we used one or the other of these A vectors to compute the heat capacity. Okay, so then we created 2 new thermo objects or instances of this class with CH4 and O2, and then in this loop we computed the heat capacity values at different temperatures between 300 and 3000, and then these final lines we just plotted the results. Okay, so that concludes this tutorial on classes and how to use them in these calculations.